For our next percentage calculation here, we link to the atmosphere. Now, the atmosphere is comprised of oxygen and nitrogen primarily. They work out to be 99% of the atmosphere, and there's 1% other gases like argon and water vapour, and a little bit of carbon dioxide. Okay, so what we need to know here is oxygen is the reactive part of the atmosphere, and often when chemicals react, they oxidize with air, they oxidize in the air. And then that oxygen joins, if you like, to the other thing that's reacting. In this question, we've got potassium. Potassium is an incredibly reactive metal. It's in group 1 of the periodic table, and it will oxidize rapidly in the air. The oxygen in the air will react with it. Now, if we do that in a sealed box, then the oxygen will essentially be used up. So the volume of that air in that box will drop as the oxygen is used. And that's what we've got going on here. So after a period of time, the volume of air had reduced to 15.8 centimetre cubed. So we started with 20 centimetre cubed, and we're left with 15.8. So 15.8 is the unreactive gases. So we're left with 15.8 centimetre cubed of unreacted gases, and 20 was our total. So if we do that and multiply by 100, then we have the percentage of gases in air that are unreactive, because we're left with 15.8. Left with 15.8 divided by the total 20, multiplied by 100, and we're getting an answer there of 79%. 79%, if you can see it on the calculator. So we know that tells us 79% of the air is unreactive. That's not what this question asks for, though. This question asks us to calculate the percentage of oxygen. That's the reactive part of air. So we need to work out the difference between 79% and 100, and that will be the percentage of oxygen. I'll let you finish that one off. All these questions, of course, on ayleshamhighchemistry.com.